All right, we are continuing our work in section 8.1 for exponential algebra. Today's focus will be on the subtracting part, but a quick review of classifying and adding. So I asked you a few minutes ago to create a third degree trinomial. What does it mean to be a third degree? It has an x to the third, or some variable to the third power. Another way of saying that would be what? Instead of third degree, what could we call it? We could call it a cubic. Yep. So you're asked to create a cubic trinomial. That means one of your variables, that first chunk, has to have an x cubed in it. It can have a number in front, right? We could make it a 5, something like that. And if it's supposed to be a trinomial, it has to have how many terms? 3. So I need 2 more terms. They can't go over a power of 3, right? That has to be the highest one. So I could have something like plus 7x minus 10. All right, that is a cubic trinomial. I could do something like 2x cubed plus 4x squared minus x. That is also a cubic trinomial. Okay? Create a quadratic trinomial that has a constant term of 10. What does quadratic mean? Quadratic means to what? Okay, we're getting confused between powers and terms, right? When we're talking about how many terms, it has a nomial at the end, right? Monomial, binomial, trinomial, polynomial. When we're talking about quadratic, we're referencing a degree. What is the degree for a quadratic? 2. 4 is quartic. They both start with Q, so it gets confusing. But think of 4 quarters in a dollar. Okay, 4 quarters in a football game. So 4 is quartic. Quadratic is 2. So we want something that has a degree 2, and we want it to have a constant term of 10. All right, give me somebody's example. What did you guys come up with? Yes. Okay, I heard 3x to the second plus x plus 10. Okay, does that fit? Is it quadratic? Yes. Is it a trinomial? Yes. 3 terms? And does it have a constant term of 10? Okay. Now it says to add the 2. So we'll go back to my first example here. And we are adding these 2 together. So we have a 5x cubed. We don't have any x cubes in this one, right? So I'm going to have a 5x cubed. When I go to combine my x squareds, this one has a 3x squared. This first one doesn't have any. So I'm going to have a 3x squared. 7x plus x. I would add those and get 8. Negative 10 plus 10. 0. Do I have to write plus 0? No. Okay. So if I were using this one and this one, this is my answer. Now obviously you guys all created your own, right? So you were supposed to add your 2 together? Okay. Any questions about doing that? Yes. No, because then the constant term would be a negative 10. So we always think of the sign going with it. Okay? So picture all of these little monomial pieces being connected with plus signs. So here where I had the negative 10, I could do plus negative 10. Does that make sense? And so my constant would be negative 10. So if they asked for a constant term of 10, it has to be a positive 10. Good question. Anybody else? Okay. Now it says, how would you name the polynomial that you got when you added them together? So based on what I have up here, yours might be different on your paper. How would we classify this? Yes. Cubic because of degree 3, and trinomial because there are 3 terms? Questions on that? All right, let's move on to our subtracting. Subtraction is the same as doing what? How were you taught how to add and subtract integers? For subtraction, what did you do? Okay, so you did plus negative or adding the opposite. That's what we typically say. So subtraction is the same as adding the opposite. I like that terminology better than saying adding a negative or plus negative, because when you change that sign, it's not always going to be negative, right? If you were subtracting a negative, it ends up being adding a positive. So we're going to think of it as adding the opposite. So in this first example, we have a 4-termed polynomial here, right? It's a quartic, x to the 4th. We're subtracting a cubic one. Now, notice that this one is not in standard form, right? They're not quite in order. That's okay, but when we write our answer, we want to put our answer in order, okay? So what we're going to do is we're going to picture this negative as if it were a -1, and we are going to distribute it to everything in that second grouping. Once we distribute that negative, we can now add the two polynomials, okay? So we are taking the first one. I think that's a square. All right, and then the second one becomes adding a -4x cubed, adding an x, adding an x squared, and adding a -2. Yes? Okay, let's look for like terms. Our highest power was this 4, x to the 4th. Do we have any other x to the 4th that we can combine with it? Okay, so then it's going to still be 3x to the 4th. Looking at our cubes. I see a cube right here. Any other cubes? Okay, so we'll still have a -4x cubed. X squareds would be next, and I have a couple of those. I have one here. Sorry, we'll do this one. One here and one here. What do we get if we take a -2x squared and add a 1x squared? What's -2 plus 1? -1. So we're going to have a -1x squared. Okay, looking at my x's. I have a single x right here and a single x right here. Adding them together, we get plus 2 x's. All right, and then last, we have some constants. We have a -7 here and a -2. Those add up to what? Okay. So final answer would be 3x to the 4th minus 4x cubed minus an x squared plus 2x minus 9. Okay? All right. For this one, first polynomial. We don't have to do anything to it, right? We just keep it the same. -2x squared plus 4x minus 1. What happens to the second polynomial? What do we have to do? Distribute that negative so we can be adding instead. So we're going to think of this as a -x cubed. Negative times negative makes this a positive x. Negative times negative makes it a positive x squared. Negative times 2 gets us a -2. All right. Where do we have like terms? Let's start with our highest piece. Highest piece would be Highest piece? The x to the third. All right. So our x to the third. Now, is that x cubed positive or negative? It's negative, right? We take this the sign that's in front of it. So we're going to get a negative x cubed. Our squared pieces, we have some here and some there. Negative 2x squared plus x squared. Okay. Our x's, we have 4 of them here, and we have 1 of them here. Okay. And our last terms, our constants. We have a negative 1, and we're combining it with a negative 2. What's negative 1 plus negative 2? Okay. So I'm going to pause the recording. I want you guys in a group to do that next one. All right. When you look at these two polynomials that we're supposed to be subtracting, are they both in standard form? Are they both in a highest power down to lowest power format?
Yeah.
Okay, that makes it easier for us to find our like terms, right, when they're in order. And I'm going to show you another way that you can write it. You don't have to. If you like how we've been writing the first two, you can continue doing that. But some people, if they were asked to add 2,379, sorry, we'll subtract 4,382. Most of the time, they would line them up, right? So the ones are in a column, the tens are lined up, the hundreds, right? That's how you were taught. So we would bring that number down here, right, so that everything's lined up. We can do that same thing with polynomials. So as I go and distribute this, I'm going to line them up vertically. Okay, I'm going to put all the x cubes in one column, all the x squareds in one column. So this becomes subtracting a negative would be positive 2x cubed. I'm subtracting a negative x squared, which makes it a positive x squared. I'm subtracting an x, and I'm subtracting a negative 10, which turns it into positive 10. Yes? Now when I add them together, my like terms visually are lined up. Okay? So how many x cubes am I going to have? So we should have 6x cubes. How many x squareds? We've got negative 5 plus 1. Okay, so we have negative 4x squareds. For the x's, we have a positive x and we're adding a negative x. Yeah, there's no x's left. You don't want to write an x at all. If you write an x, you're saying there's one of them. Okay, we don't have any x's. Looking at our constants, a negative 3 plus 10 should give us a positive 7. Okay, so again, either way, whatever you prefer. If you want to line them up vertically, that's fine. If you want to just leave them all in one horizontal big line and find your like terms, that's okay too. All right. The last little bit that we're going to look at involves some word problems where we're asked to do some adding and subtracting of polynomials. Okay? So the first thing, we want to list ways or words that we might see that would tell us we should be adding, and words that we might see that would imply that we're supposed to subtract. Okay? So talk at your tables. Are there any words that you've seen in word problems that would tell you to be doing either adding or subtracting? All right, some words that mean adding. Stephen. Sum. As in S-U-M? The sum of things means you're adding? What other words might you see that mean adding? Total. Okay? Now, you have to be a little bit careful because depending on how the phrase is, total could mean some different things, right? More than. I'll give you an example. We're not talking about the greater than inequality, right? If I said I have $4 more than you do, I could take your amount and add 4 to get my amount. Does that make sense? Okay. Anybody else have some that would imply adding? Raised. Okay. Now that's coming from the word problem we're going to talk about in a minute. So we'll revisit that. Yes. Okay. All right. Anybody else have something they want to add to the adding part? Okay. Subtracting. What words came to mind? Okay. So if more than means we're adding, less than would mean we're taking away. Okay. Difference. Sum and difference are used quite a bit for adding and subtracting, right? The sum of two things, the difference of things. Other things? Okay. Again, that the raised and spent idea is coming from this word problem that we'll talk about. Takeaway? Okay, they might just say subtraction. Yep. Takeaway? So putting things together, taking things away. All right, so let's look at our first example here. It says the amount of money that you raised doing a fundraiser is represented by 15x minus 100. So we have a linear what? 15x minus 100 is a linear binomial, right? So we have a linear binomial being used to represent how much money we raised. Then it says the money that we spent advertising and things for this fundraiser was 10x minus 50, another linear binomial. Write a simplified expression for the difference between the amount that you raised and the amount that you spent. Okay, so in this case, the word difference is telling you that we're subtracting, right? The amount raised means something that we gained, right? The money we gained in the fundraiser, as opposed to how much we spent. So I am going to caution you that in this context, when we talk about raised and spent, raised is how much we made, spent is how much we're spending, right? The stuff we're taking away. So we are doing how much we raised minus how much we spent. Yes? So I would be cautious of saying raised always means adding and spent always means subtracting. It depends on the context. Okay? So in this context, raised is how much money we took in, spent is how much we used up on promoting the fundraiser. All right, so our expression was 15x minus 100 for how much we raised. Then it says we're subtracting how much we spent, 10x minus 50. All right, let's go through and rewrite it, distributing that negative sign. So we have 15x minus 100. We're subtracting 10x. And we are subtracting a negative 50, which means we are adding 50. All right, so what's my new expression going to be? Agree, disagree? 15x minus 10x would be 5x. Negative 100 plus 50 would be negative 50. Okay, so that is our simplified expression for the difference between those two amounts. Then it says, if we raised $2,000, what does X represent? So go back and look at how much we raised. Was this? Okay. If we know that that has to equal 2,000, can we figure out what X is? Can we solve that for X? Yes. What would we do first? We'd have to add 100. So we have 15x equaling 2100. Exactly, we divide by the 15. So grab your calculators. What is 2100 divided by 15? You have 21,000 instead of 2100. Okay, so 14. Yes? Did we get 14 or not? Yes? Or 140? What is it? 140? So 2100 divided by 15 is 140? Yes? Seems more reasonable? Good. All right. So if x is 140, can we then figure out how much we spent? The amount spent was represented by this, right? And if we know that x is 140, can we plug it in? All right. So we have 10 times 140 minus 50. What's 10 times 140? 1400, yep. 1400 minus 50 would give us, okay. Questions about that process? All right. We've got one more problem for you. It is not in your notes, but you have space at the bottom. Okay? You don't have to write it down necessarily the way it's written here. You could just sketch a picture. All right? It says, the floorboards that border around the outside of a room is given by 4d squared plus 11d minus 3. It says we know 3 of the sides. One side has board lengths of 5d, another has 4d plus 3, and a third side is 2d squared minus 1. The question is asking what's the length of the fourth side of the room. Now, this isn't necessarily a rectangular room, correct? Because all the other 3 sides were given by different expressions. Okay, so we have a 4-sided room, okay? And we know that one side is 4d plus 3, one side is 2d squared minus 1, and one side is 5d. We also know that the total all the way around the room, what do we call that? What's the name for that? If we go all the way around the outside? The perimeter, good. We know that the perimeter is 4d squared plus 11d minus 3, okay? If we know the whole distance around, we know that perimeter, and we know 3 sides, what could we do to find the fourth side? Okay, so one option would be add up the 3 sides that we know, and then subtract that off from the perimeter. Could we subtract each one individually? Perimeter minus the first side, then minus the second side, then minus the third side. Yes? That would work too. All right, which one do you want to use? Add them all up first? Okay, so let's add up. We have 4d plus 3, we're adding 2d squared minus 1, and we're adding a 5d. What do we get for those 3 sides combined? Okay, good. Start with the 2d squared, highest power down to lowest. Okay, those combine to be a 9d. Yes? And then we have a 3 minus a 1, so we get a 2. So the 3 sides add up to 2d squared plus 9d plus 2. What do we have to do with that? Subtract them from the perimeter. Okay, so we are taking this perimeter and we're subtracting this. Yes? All right, so 4d squared plus 11d minus 3. We're subtracting all of this. which means we have to distribute that negative sign. So minusing 2d squared. We're subtracting 9d. Oops. And we're subtracting a 2. We okay with that? All right. So looking for our like terms. How many d squareds are we going to have? 2 of them. So we have 2d squareds. Are just regular d, the linear one. We have 11 and a negative 9. We have 2 of those. And our constants. So we have 2d squared plus 2d minus 5 is that missing side. Yes? Okay. You're doing 11d plus a negative 9d. Right? Take the sign with the number. Think of this as a negative 9 when you move it to combine with things. Okay. All right, so I will get the worksheet out to you.